Okay, so Bitcoin, it's like everywhere you turn, right? But how many of us can actually say we really get what's going on under the hood? Well, that's what we're tackling today, and we're lucky enough to have some amazing insights to guide us. We're diving deep into Andrej Karpathy's, the AI mastermind over at Tesla, his blog post, A From Scratch Tour of Bitcoin in Python.
And what makes this deep dive so insightful is that Karpathy gets it. He understands that to truly grasp this technology, you got to go beyond the theory. You got to build it.
Yeah, it's kind of like instead of just reading about how to bake a cake, we're going to actually gather the ingredients, measure everything out, and pop it in the oven ourselves.
Exactly. And when you build something from scratch, you understand it at a whole other level.
And speaking of getting our hands dirty, let's talk about your Bitcoin identity, your cryptographic keys.
This is where it all starts. A secret key and a public key. Think of your secret key like a high security password, but for your Bitcoin.
Okay, so far so good, but I gotta ask, how secure can a random number really be?
That's the beauty of it. This isn't just any random number. This is where the magic of elliptic curve cryptography comes into play. Without getting too lost in the mathematical weeds, picture this. A point bouncing around a really complex curve, and the path of that point, that's determined by your secret key.
And that makes it virtually impossible for someone to just guess.
Exactly. And if you lose that secret key, say goodbye to your Bitcoin.
So this secret key is clearly super important, but I imagine we can't just share it with everyone.
Definitely not. And that's where the public key comes in. It's like a scrambled version of your secret key, one you can share without compromising your Bitcoin.
Got it. So it's like a disguise for our secret key. But how do we go from a public key to an actual Bitcoin address we can use?
That's where those cryptographic fingerprints, those hash functions, come into play. They take your public key and generate a unique code. That's your Bitcoin address.
It's incredible, actually. Even the smallest change to your public key creates a completely different Bitcoin address. It's like Karpathy actually goes through the effort of implementing one of these hash functions, SAJ256, totally from scratch in his blog post. It's wild.
Yeah. And it really highlights the sheer complexity of what's happening behind the scenes, even with something as seemingly simple as generating an address. And this complexity is what makes Bitcoin so secure.
Okay, so we've got our secret key under wraps, our public key is out there doing its thing, and we've got a Bitcoin address to receive Bitcoin with. But how do we actually send and receive this stuff?
Well, that's where Bitcoin transactions enter the picture. And here's where things get even cooler. We're not really dealing with accounts like in traditional finance. Instead, we've got these things called UTXOs.
UTXOs sounds a little intimidating, I gotta admit.
It's not too bad once you wrap your head around it. Think of them like individual bills in your wallet,
Yeah.
right? So say you've got a $10 bill and you want to grab a coffee that costs $4. You hand over that $10 bill, but then you get some change back, right? Well, in Bitcoin land, that initial $10 bill, that was a UTXO. When you buy your coffee, you're essentially creating two brand new UTXOs. One for $4 that goes to the coffee shop, and another one for $6 that comes back to you as change.
Okay, I think I see what you're saying. So every time we're transacting in Bitcoin, we're basically chopping up these UTXOs and creating new ones from them.
Exactly. And to keep everything running smoothly and make sure everything's above board, every single transaction has to be structured in a very particular way. It uses a scripting language called, and it's not as scary as it sounds, Bitcoin script.
Hold on, Bitcoin has its own whole programming language. Getting intense now.
It's not as daunting as you might think. Think of it like a way to set up conditions for spending Bitcoin. So each transaction has these conditions baked in. They're called locking and unlocking scripts.
So like a little cryptographic puzzle that needs solving before any Bitcoin can actually be spent.
You got it. The locking script, which is attached to that UTXO we talked about, that's setting the challenge. It basically says, hey, if you want to spend this Bitcoin, you got to prove, the secret key that matches this specific Bitcoin address. And that's where the unlocking script, which is part of the input to a new transaction, comes in. It provides the solution to that puzzle.
Interesting. But how do you prove you've got the secret key without actually, giving away the secret? Seems like a neat trick.
That's the beauty of digital signatures. It's a really cool bit of cryptography that Karpathy breaks down in his post. Think of it like a digital fingerprint. It confirms your identity without you having to reveal your actual fingerprint. Basically, you use your secret key to create a unique signature for every transaction. It's proof that you're authorized to spend that Bitcoin, but you never actually expose your secret key in the process.
So we've created our transaction, we've got these clever scripts in place, and we've digitally signed it to show it's all on the up and up. What's the next step? How do we actually get this transaction out there into the Bitcoin universe?
Well, that's where broadcasting comes in. Once you've put together your transaction, you broadcast it to the whole Bitcoin network.
The whole network, like shouting it from the rooftops.
Pretty much. It's more like sending a digital message to every computer in the Bitcoin network, hoping someone will pick it up and verify it. And those someones are our trusty miners.
Right, the miners, we've mentioned them a few times, but we haven't really dug into what they actually do.
They're a vital part of how Bitcoin works, that's for sure. They take your transaction, along with bunches of others, and they try to add them to the blockchain. Think of the blockchain like a huge public ledger that keeps track of every single Bitcoin transaction ever made.
So it's like a giant digital accounting book,
Yeah.
and the miners are the ones meticulously updating it.
That's a great way to put it. And here's the really cool part. Miners don't just add these transactions randomly. They actually have to compete to do it.
Compete? You mean like it's a race? Tell me more.
It's a race of sorts, but it's a race to solve super complex math problems. The first miner to crack the code, they get to add the next block of transactions to the blockchain. And get this issue. They get rewarded in Bitcoin for their efforts.
Whoa, so they're basically getting paid in Bitcoin to make sure the whole system stays secure and accurate. That's pretty ingenious. How does this competition actually work, though? What are they doing with these mathematical problems?
Well, that's where we dive into the fascinating world of, you guessed it, cryptographic hash functions.
Okay, so we've got these miners in a constant race, crunching numbers like crazy to solve these cryptographic puzzles, all to add the next block of transactions to the chain. But how does it actually work? What are they doing with these math problems, and why do they have to be so tough to solve?
Remember those hash functions we talked about? The ones that make those unique fingerprints for our Bitcoin addresses? Well, they're back, and they're crucial for this whole mining competition. Imagine each block of transactions as like a jigsaw puzzle. The miners are trying to find the missing piece, the one that makes the whole picture come together. That missing piece, it's a specific number called a nonce. When you add that nonce to the block of transactions and run it through the hash function, it has to produce a result that meets certain rules set by the Bitcoin network.
So they're searching for a needle in a haystack, a needle that makes this whole cryptographic puzzle fit perfectly.
That's a great way to put it. And here's the really ingenious part. The difficulty of finding this needle, it actually changes automatically. It adjusts based on the total computing power of the entire Bitcoin network.
So if more miners join the network, trying to grab those Bitcoin rewards, the puzzles get harder to solve.
Exactly. More miners, tougher challenge. Fewer miners, easier challenge. This keeps the whole system balanced and makes sure a new block is added to the blockchain roughly every 10 minutes, on average.
It's like a self-adjusting system, always keeping things in check. That's amazing.
It really is. And it's one of the most innovative parts of Bitcoin. You see, because this mining process is a competition and the blockchain itself is decentralized, it means no single person or organization can control Bitcoin. It's incredibly difficult to manipulate.
There's no central bank calling the shots, no government pulling the strings. It's a completely different way of thinking about money, isn't it?
Completely different. And that's a huge part of what makes Bitcoin so revolutionary. Because the blockchain is spread out across tons of computers all over the world, it's virtually impossible to shut down or mess with. And every single transaction, it's recorded on this public ledger for everyone to see.
It's like a global spreadsheet, impossible to erase or tamper with. Everyone can audit it, but no one can fudge the numbers.
Exactly. And that transparency, along with all the security we've been talking about, that's what gives Bitcoin value and the potential to really change how we think about money and finance in general.
This whole deep dive has been mind-blowing, honestly. We've gone from zero to, well, maybe not hero, but we definitely know a lot more about Bitcoin than we did an hour ago. We covered so much, making Bitcoin identities, understanding those intricate transactions, figuring out what those busy miners are up to, and the elegance of the blockchain itself.
And remember, we're just scratching the surface here. Karpathy's blog post is a fantastic starting point, but there's a whole universe of Bitcoin knowledge out there to explore if you're interested.
That's right. Our goal was to unpack those core concepts, but now it's up to you to follow your curiosity. Maybe you want to dive deeper into SegWit, which is tackling those scalability challenges, or maybe you're intrigued by the Lightning Network, promising faster and cheaper transactions. And then there's that whole world of smart contracts and decentralized finance built on Bitcoin, too. Whatever you choose to explore, just remember what we learned today. Bitcoin's not just some mysterious internet money. It's a groundbreaking technology built on really clever cryptography, ingenious engineering, and a good dose of those economic incentives.
It's a testament to human ingenuity for sure, and it shows what happens when you decentralize power. Who knows what the future holds for this technology?
One thing's for sure,
Yeah.
it's going to be exciting to watch it unfold. Thanks for joining us for this deep dive into the heart of Bitcoin. We'll catch you on the next one.